This video will be for 4.3 concavity and the second derivative test. And we're going to do 3-response question from your packet, 1999, question number 4. So suppose the function f has a continuous second derivative. So f double prime never is undefined for all x, and that f of 0 equals 2. I'm going to actually rewrite these things down here. F prime of 0 equals 3, or sorry, negative 3, and then f double prime of 0 equals 0. Let g be a function whose derivative is given by g prime of x is equal to e to the negative 2x times 3 f of x plus 2 f prime of x for all x. Part A just asks you to write the equation of a tangent line to the graph of f at x equal to 0. So part A is pretty easy because you're going to be using the graph of f. We actually have everything we need. Y minus 2 is equal to the slope at 0, x minus 0. Remember that the formula we're using here is y minus y1 is equal to m times x minus x1, where this is the point that we're going to make the tangent line at, and this is actually the derivative at that point. So there's your part A. Part B, is there sufficient information to determine whether the graph has a point of inflection at x equal to 0? So we're talking about graph of f, and we want a point of inflection. So point of inflection happens when f double prime of x is equal to 0, and f double prime of x changes sign. And if we look up, we didn't get enough information to actually answer that question. So at the very top, all it gave us in terms of f was this part. F double prime has to change sign. There's insufficient information to determine if f double prime of x changes sign at x equal to 0. Letter C, out of the way. So suppose that f has a continuous second derivative, so that's the beginning. We are now going to start talking about the function g of x. And if you look here, first it's telling us that g of 0 is 4, and we're going to write the equation of a tangent line at x equal to 0. So we have the point, and now we need the slope. The slope would be g primed of 0. So the first thing I need to do is use that g prime they gave us and substitute in 0 times 3f of 0 plus 2f prime of 0. And what's nice is the values were all given. The actual derivative formula was already given to you. So e to the 0 times 3 times f of 0, which at the very beginning they gave us was 2, plus 2 times f prime of 0, which they gave us was negative 3. So we get e to the 0 is 1, 6 minus 6, and so we actually get that g primed of 0 is 0. The equation then would be y minus y1, which is 0, is, oh sorry, no it isn't. y1 is actually this point down here, is 4, is equal to the slope times x minus the x value. Now, there's a lot of zeros in there, so really, if we want to simplify that, you would end up with y equal to 4. This is a horizontal tangent at x equal to 0, comma, y equal to 4. Therefore, the equation of the tangent line is a horizontal line, y equal to 4. Last part, part D, show that the second derivative is equal to that equation. Does g have a local minimum at x equal to 0? So let's start with just finding the second derivative. So given the first derivative, g prime of x is equal to e to the negative 2x times 3f of x plus 2f prime of x. I can tell that I'm going to have a chain rule based off the e right here. And then I also have a product rule because we're multiplying the e times this part of the function. So off to the right, in case you're having trouble, I'm going to find the derivative of e to the negative 2x. Remember that's e to the u times the derivative of u. So you actually get negative 2e to the negative 2x. I'm also going to find the derivative of the second part of 3f plus 2f prime. And that actually just becomes 3f prime plus 2f double prime. So now we have all the parts to do our product rule. So I'm going to do the product rule to the left. Second derivative would be leave the first function alone, multiply by the derivative of the second, and that's this pink part right here, which is 3f prime of x plus 2f double prime of x, plus leave the second part alone. So that's the original second piece of the function. Multiply by the derivative of the first piece times negative 2 e to the negative 2x. All right, so we end up with, move this off to the side. We're going to end up with, let's see, g double prime of x is equal to, you want to stay away from trying to multiply everything out. You want to see if there's common factors because of the fact that this is such a long derivative. You'll notice that both terms have e to the negative 2x. So I'm going to actually factor that out. When I factor that out, my leftover pieces would be, for the first term, 3f prime of x plus 2f double prime of x. My second term is all of this. And notice that the negative 2 is being multiplied. So I actually have to do plus negative 2 times 3f of x plus 2f primed of x. And that's in its own parentheses before we close the square bracket. So if you want to double check, if I multiplied the e back to both terms, you'll end up back with the original. People get really confused that you're really putting a plus in between. It's because, and I'm going to highlight, this here is term number 1, and this here is term number 2. And so when I factor out, I'm still going to have the plus right here. So next step, I'm going to simplify if possible. Let's see if anything simplifies on the inside of the derivative. Let's see. It looks like we end up with, and I'm going to write it down here, negative 6 f of x minus 4 f primed of x, and that's me distributing the negative 2. I am going to see now common terms. It looks like in terms of f of x's, I only have negative 6 f of x's. The primes, I have 3 and negative 4, so I get negative f prime. F double primes, I have 2, and I think that's it. So plus 2f double primed of x. And if you look up, that's the exact value, or sorry, the exact function for the second derivative. Now, there was a part 2. Does g have a local maximum at x equal to 0? So I'm actually going to take that question to the next page. So we did get the second derivative. I want to go back and pick up the first part of the question because there's going to be information in there that we're going to need. All right. So we have the second derivative here. Notice they're asking us for g to have a local max at x equal to 0. So there's two ways that you could have a local max. You could take g prime and show that at 0, the derivative is either 0 or undefined and changes from plus to minus. The second way that we could define a maximum is if we know that g primed at that point 0 is 0, then we would need the second derivative at 0. If it's bigger than 0, meaning positive, then the function is concave up, which gives us the minimum. If I have g prime of 0 equals 0 and g double prime of 0 is less than 0, then it's concave down, which will then give us the maximum. So if you look at the two different ways, you can't use number 1 because of the fact that we're not given enough information about g to be able to make a sign chart. Meaning, we have the second derivative, but you don't know enough information about this f function everywhere. Oh, sorry, the first derivative, which is up top. Let me clear that out. Which is here. The first derivative uses f of x and f times of x. All they gave us were values at 0. So we can't substitute in a number that's negative or a number that's positive so that we can get either side of 0 to make a sign chart. Therefore, sign chart won't work. We have to use the second derivative test. So the second derivative test says if at x equal to 0, we know that g primed of 0 is 0, which we found in one of the earlier parts. We just have to show what the second derivative value at 0 is. So I'm going to use this function here, and we have e to the negative 2 times 0 times negative 6 times f of 0 minus f primed of 0 plus 2 f double prime of 0. And if you remember at the very beginning, they actually gave us all those values. So e to the 0 is 1. We get negative 6 times f of 0, which is 2. And that value I'm getting, if you look up top from here, minus f primed of 0 is negative 3, plus 2 f double primed of 0, if you look up top, is 0. So I used next f prime of 0 and f double prime of 0. Now I'm just going to find what this value equals. We end up with 1 times negative 12 plus 3, so we end up with negative 9. What that tells us is at x equal to 0, f of x is concave down. Now that we know that it's concave down, the curve would look like this. But remember the very beginning, we know that the derivative there is 0. The only way that could happen is if at x equal to 0, there's physically a maximum. So the maximum tells us that the g prime of 0 is 0 and that the g double prime is negative, meaning concave down. So do we have a local maximum? Yes. We have a local maximum because of the second derivative test. The first derivative is 0, and the second derivative is negative, forcing the function to be concave down. And I'm going to show you the last page. This is the physical answer key that tells you how many points you would get for each part. So if you want to go through and check your own physical answer to see how many points you could get out of 9, you can pause the video right here.